can you give a quick introduction to what is cognitive computing?
Yeah, sure.
And how Watson works?
So cognitive computing is a computing system whose purpose primarily is to deal with what I call the human condition, which is our human forms of expression, textual, visual, auditory, the things that we are used to as humans using for communicating our ideas and really kind of manipulating those ideas intellectually. And of course, what we tend to do as humans is to write down all of our ideas. We tend to, put that in blogs or tweets or in papers or books. And the problem then becomes, well, it's in a form that humans can understand, but typically computers have not been able to understand because it's very hard to model sort of the math of grammar in a mathematical model. So traditional computer systems have just not been able to tap into all of that information that has been produced, whereas cognitive computing does. Cognitive computing attempts to get to sort of the essence of what we're trying to say. What is the real intention of our expression for the purposes of being able to find information that we can then use for making decisions or to, navigate our life in a more effective way. That's what cognitive computing is doing. It's really just trying to understand all of that expression and bring that to our fingertips to make better use of.
And I know you are now adding additional forms of human expression, which we'll talk about later. But what Watson is mainly known for is natural language, so that you can pose it natural language questions. So are there particular types of questions for which it's more suitable?
So this is evolving, and it did start with a fairly narrow type of question. If you look at the Jeopardy game, for example, those questions were essentially factoid questions. They were looking for facts, the noun phrase, in literature that might serve as a good answer to whatever question is being asked. And the reasoning strategy that had to be employed to achieve that was very particular to answering those kinds of questions. As we brought this into the commercial realm, we first started looking at the questions that doctors might need to ask in order to identify the best treatment for their patients. And that actually required that we be employing a different reasoning strategy, not just looking for the facts as written in literature, but looking for, what are the pertinent clinical information that might be captured in clinical notes? What are the potential adverse events that could occur as a result of one treatment or another? And so we built a different reasoning strategy for that. Later, then we created a reasoning strategy for finding sort of descriptive answers. The difference between what is the capital of Texas, which is a factoid, versus what does it take to get insurance in the state of Kentucky, which is more of a descriptive, it's asking for a descriptive answer, again, required a different reasoning strategy. As we continue to build out these different dimensions of the human condition, we're building in new reasoning strategies to evaluate these kinds of questions in a different way and then fuse those together so that we can actually use different reasoning strategies for different kinds of questions, even though you may not know in advance what kind of question you're going to ask.
And I know one thing that you use to answer some of these more descriptive questions, because, it's whether, Dublin is the capital of Ireland is a kind of yes or no answer, and everybody kind of agrees. Right. But you also have, for the more complex questions, things like confidence measures and evidence. And I know you have worked a lot on oncology and using Watson within oncology. So can you tell us a little bit more on how you get doctors to actually work with the software and to start to trust it, actually?
And that's the key thing. We talk about this in terms of expertise. If you think about what do we measure in experts in the human world? Why do we consider certain people to be experts in their field? It's not just that we think they can answer all of our questions in that field, although we expect them to be able to answer a lot of them, but we expect them to be transparent about their rationale. Why did they come to that conclusion? What was the reasoning? What was the supporting evidence that led to that particular conclusion? And what confidence level do they have in that conclusion? Those elements of the human form of expertise are essential to our developing trust in those people that we consider to be experts. Well, the same thing's true of these cognitive systems too. for them to be trustworthy, they have to be able to defend their rationale, and therefore they have to be able to sort of expose the supporting evidence, the logic of the reasoning that went to why it came to that conclusion, and it has to be able to measure its relative confidence to, in some cases, come back and say, I don't know. You know, part of what I consider to be an expertise of my doctor is that I expect him or her to come back and say, I don't know the answer to that question. I don't understand that disease. I don't know how to treat it. But here's somebody who can. Here's somebody else who I trust, or somebody I can defer to, or a different source of literature I can go to go get better answers. Those are things that we're looking for in these cognitive systems too.
Because you explained that if you don't know somebody, for example, or maybe if the thing they're giving you advice on is really important, you expect more evidence and you expect more explanation of how they came to that conclusion that if you've dealt with them before and you kind of trust their expertise.
Yeah, exactly right.
So it's the same with intelligent software, essentially, you're saying.
Correct, right. And so, I mean, to some extent, the threshold of confidence that an expert system has to have is similar to what we as humans have as well. If you aren't aware of it, you know, it might be worth spending some time thinking about it. Next time somebody asks you a question, there's sort of this internal voice that we have that says, how certain am I about the answer I'm about to give? And just like in our human relationships, where the first time we meet, there's a tendency for us to be a little bit more conservative. You know, that voice is a little bit louder. We often will sort of say, well, I need to be really, really certain before I decide to give an answer back to this, because I actually don't know how that person's going to take my response. I don't know how they're going to react to it. I don't know what they're going to do with that information. I don't know what sensitivities they have. And so I will, at least in my own case, be a little bit more conservative the first time I meet them. But as I get to become more familiar with them and begin to understand what they're more likely to do with the information I provide them, or how they're going to react to it, how they're going to assimilate the information I provide, then I will get more informal with them. And, you know, after many years, you know, I might even be very informal with them. But on the other hand, you know, you have to kind of understand that and adjust according to the context and how strongly you have an understanding of your relationship with them.
So it looks like in the future, and this is something that's been written a lot about lately, we'll have either robot colleagues or intelligent software as colleagues. So from watching doctors who are highly expert in their field, work with Watson for a couple of years, what have you learned about what you think how that interaction is going to work?
So most of the interactions that we see today in practice are ones where it's not literally about asking a question and getting an answer, but applying the cognitive capabilities in the framework of whatever workflow they're a part of. So a doctor, for example, you know, will spend time understanding their patient, will spend time understanding and diagnosing whatever disease they might have, and spend time trying to find an appropriate treatment. All of those may have questions associated with them, but to the extent that the cognitive system can anticipate what the doctor needs and be able to insert itself into that workflow, especially if doing so can be done in a way that reduces the amount of time that is taken away from the patient, then it will be used. And it's something that the system will be able to provide more value to. Doctors do not like having time taken away from their patient. They really want to spend more time with the patient, not less. They don't like computing systems in general that require that they spend more time with the computer than they do with the patient. So this is sort of the trick and the requirement of cognitive systems to have utility. They have to both answer the question, anticipate the question, and do so in a way that requires less time. As we evolve, you know, the vision that we have for cognitive systems is that they sort of become, you know, the third person in the room. You know, able to kind of watch the conversation as it progresses, understand the context that develops along with that conversation, and have that in the backdrop so that when it does come time to ask it a question or insert it into the workflow, it has that context so that it can be able to do that better. So it can disambiguate the kind of question that might be asked or determine the most appropriate kind of answer that is relevant to that particular situation. And one of the things that we've seen is that third person is going to be embodied in some way. I mean, the idea that there's a microphone on the wall.
In a social robot or something like
yeah,
this.
the idea that there's a microphone on the wall and speakers in the ceiling, is awkward for most people in a social context. So, something that embodies that in a slightly more anthropomorphic form, a social robot, for example, is much more natural for people to interact with than this invisible force that's sitting out there out in the ether.
And you told me as well that you're working on not going past natural language to be able to interpret things like body language, intonation, and all of these other cues which we use to interpret what somebody really means.
That's right. That's right. It's devices that you and I use as humans to do a better job of communicating with each other and understanding each other. Even as I speak, it's not just my words. It's the way that I vocalize those words. It's the intonation and the cadence and the sort of the representation, the vocal representation that I give it that punctuates certain things that I'm trying to say that allow you to kind of understand my point a little bit better, whether that's in the form of a question or in the form of a response or vice versa. And then, of course, take that even further. As I sit here watching myself, use my hand gestures. Those hand gestures, they punctuate. It's very hard to, make a comment about something, about this and that or here and there without resolving what that means with a hand gesture. Likewise, our facial expressions, our body posture, and everything else are important features of how we communicate. And that's part of what we're looking for in the cognitive system, too, to affect its ability to communicate with us.
And I know you've already actually released a set of APIs, 32 APIs you said recently, that
That's
also
right.
cover stuff like image recognition, facial recognition. You're not quite as far as body language or intonation yet, but there's an awful lot of different functions in there. And part of the idea of that, I think, was to make Watson more accessible beyond big companies.
Yeah.
So can you tell me a bit about that and what people are doing with it?
Yeah, absolutely. And that's exactly right. It didn't take us long, after we played the game of Jeopardy and people started coming forward with different ideas, to realize that there were so many different ideas of how to apply this technology that we certainly couldn't do it all. It was bigger than us as a company. And so we decided that it was important to open this up, to make it possible for anybody to access the cognitive services and start to leverage those within their own ideas. And as a consequence of that, we've had a tremendous uptake. We have a lot of companies now that are all in the business of creating applications and bringing those to market. We have 400 vendors that are now signed up to create applications. We have 100 applications in market that those vendors have produced. And the numbers are just growing enormously. And the kinds of things that they're doing are, ranging from, we got one that's building software for veterinaries, people that, are in the business of providing health for their pets. We have people that are building applications for sports trainers, right? To have software that is reading the very latest literature about training techniques and the science of sports medicine and how to apply that to improve their exercise regimes for their sports professionals or amateurs even. We have one that's building a toy dinosaur that has a speaker and a microphone, a processor and a Wi-Fi connection that is targeted at little kids that, can interact with it, can answer the child's questions, can tell the child riddles or stories, can challenge the child at different educational exercises, and out of which we can begin to watch the behavior between the child and the toy to begin to provide some very early detection of
developmental problems.
Developmental problems,
like
right, and inform educators so they can do a better job of teaching that child.
All right, so everything from oncology to toys.
Yeah, that's right.
So if anybody wants to use some of the capabilities of Watson, it's there in the API now.
That's
so
right.
Thank you very much, Rob.
Absolutely, thank you very much.
And thank you, everyone.
Thank you.